Okay, this is my practice for mixed capacitors. And the objective of this practice is to calculate the total capacitance of the circuit. And after getting that information, we can use the voltage to calculate the total charge of the circuit. To do this, we're gonna simplify the circuit until we get a single capacitor that will have the value that we're looking for the total capacitance. The first thing we have to do when we analyze a circuit is see what we can solve right away, and the only one that pops into view right now is these two capacitors that are in series. So to calculate them in series, all we have to do is calculate the inverse of each value of their capacitance, add it together, and then get the inverse of the result. We have it right here. So it's 6 microfarads elevated to the power of -1 plus 12 microfarads elevated to the power of -1 as well. And then we elevate that to the power of -1. This is wrong. And that will give us our equivalent capacitor number 1, which is 4 microfarads. We can replace these two with our equivalent capacitor. And now we see that it will be easy for us to simplify these two as they are in parallel. And for this we just have to add it together. So our total capacitance will be equal to 10 microfarads by adding 4 and 6. Once we know our total capacitance, all we need to do to calculate the total charge is just multiply the total voltage by the total capacitance. And since we're dealing with volts and microfarads, what we're going to have to do is type this microfarads in scientific notation. That's why here we have 10 volts times 10 times 10 to the power of -6. And the result of this is 0.001 coulombs. This could also be 1 times 10 to the power of -3. And that way we calculated our total capacitance and our total charge of the circuit.